The full life cycle of an excavation is an extensive process that will go through many different teams across Skanska. To understand how this process works from start to finish, we are going to focus on pre-construction, issue of permits to break ground, tracing techniques, and safe digging practices. We always follow the principles of prevention and lay out steps to eliminate, reduce, isolate, or provide engineering controls to minimize all hazards. Initially, the pre-construction information, or PCI, is obtained. Asset owner restrictions are determined, as each utility may be the responsibility of a different organisation. Desktop surveys are carried out by referencing existing utility drawings of the area. At this point, asset owners of high-risk utilities are to be contacted to request isolation or diversion as required. Designers will visit the site, referencing the desktop surveys. They compile more on-site information for the plans, including proposed excavation locations and any visible obstacles and optioneering around which methods of construction shall be employed. This will lead to the development of the designer's risk register and design risk assessment, which is a key component to removing any risks to the on-site teams. A handover session will take place to ensure all information is transferred from the design team to the project management team. Residual risks will be identified and controlled. This will inform construction teams of the detail and measures required during the construction. Our technical connection and digital project rehearsals are a good example of how Skanska are harnessing technology to ensure that we eliminate or minimize all construction risks. These also supplement RAMs and provide excellent guidance to operational teams on excavation and construction requirements prior to handing the design over to the project and construction management teams. A handover session then takes place between the project management team and site management team, and finally handover between the site management and construction teams, supplying a handover pack with the RAMs, utility plans, site plans, temporary works design, and any other documents as required. Prior to excavation commencing, a trained underground services appointed person, or USAP, must review all of the information and ensure it is to the Skanska standard before issuing the permit to break ground. The USAP must check approved designs and utility information is available and has been reviewed for suitability. The permits requested are checked they have been provided in advance of work activity. The competence of the working team is reviewed, with key personnel having the right qualifications and experience. The USAP also ensures a CAT and generator scan has completed in all modes, including depth, using all appropriate accessories. All services are checked they are correctly marked, including encroachment lines. The different levels of survey required is assessed and carried out based on the risk profile of the work and also on client requirements. The USAP will then issue, authorise and ensure the full briefing of the underground service avoidance permit to the working team. The details of all authorised permits are entered into the permit register. The USAP will monitor conditions of the permit during work activity, including identification of the surfaces in concrete or any other obstructions. Finally, the USAP will manage the closing out of permits upon completion of activity. The tracing or utility detection survey will confirm where services are located underground. It is also key to identifying obstacles and preventing unexpected delays. To begin, we must perform the pre-use checks on the Genny and CAT, checking the equipment for any signs of damage. Check the batteries in the CAT by squeezing the trigger and listening for the chirp. There is also a battery icon, which will flash when the batteries need to be changed. The calibration date then needs to be checked by squeezing the trigger and hitting and holding the button on the top when the display turns on. The screen will display the configuration code, software version, followed by the calibration due date. A function test can now be performed by placing the Genny 15 meters away on induction mode, setting the CAT to Genny mode with maximum sensitivity and pointing it towards the Genny. A clear signal should be heard. A utility detection survey should always be started with a Genny, looking for known services. A volt stick is used prior to touching any metallic street furniture, mains, or services in the excavation area. It is recommended to locate street lighting first by connecting onto the metal column. This technique has the potential to save time, as in some situations the street lighting is connected to the LV main. And by applying a signal to the lighting cable, we may be able to locate the LV main and even the LV services to nearby properties. You must remember though, that if the street lighting is in a loop-in, loop-out system, which is separate to the main LV network, then only the street lighting circuit will be located, and more work must be done. It is important to note that modern housing using the PME system can often lack a physical ground at the property, making it very difficult for a Genny signal to travel from the main to the house. In this instance, a connection to the property should be made to allow the signal to travel back to the main. When tracing a street light cable, ensure you place the earth pin very close to the column. This will allow the Genny and its leads to remain in close proximity, and in turn allow us to work as close to the column with the CAT as possible. The earth pin can be put into the ground at a shallow angle to minimize any contact with underground services. If there is no soft ground available, water can be used as an earth. With the Genny turned on, connect one lead to the earth pin, connect the other to the column. A change in tone should indicate that a good circuit has been made. If you find it difficult to get a connection to the column, i.e. a concrete column, a capacitance technique can be used by wrapping the cable around the column. Please note when using capacitance techniques, there is no tone change from the Genny. At this point, the Genny can be muted by turning it off and then pressing and holding the button. Before we locate the lighting cable, we should disable the strike alert feature to avoid getting confused by any false alarms. To do this, press and hold the button on top before you squeeze the trigger. Start around 2 meters from the column, and keeping the CAT still at the side of your body, perform a series of circles or semicircles around the column to localize the signal. Once you've localized the signal, narrow down the sensitivity control to pinpoint. Rotate the CAT through 90 degrees and align the CAT to the maximum signal level. The cable is now at 90 degrees to the CAT. The cable can now be followed and traced. It is important to follow the signal and note any sudden change. For example, a sudden loss of signal over a short space usually indicates a branch has come off the line. You have passed over the joint. Depth estimation can now be performed. The reading from the CAT is distance. Therefore, if the CAT is not directly above the cable, but off to one side, the reading will be greater than the actual depth. It is vital to ensure the CAT is directly above the cable. Do not take a depth estimate near a bend or T-junction or in the presence of multiple Genny signals. Take a depth reading by pressing and releasing the button. This reading must now be tested for reliability by raising the CAT a known height and repeating the reading, which should now have increased by the amount raised. Note, holding the button rather than releasing will perform the snowed depth, and when this is done using the Genny, the reading will be incorrect. Once the street lighting has been detected and marked, we now need to use the Genny to locate the remaining LV network, both the mains and the LV services. To apply a Genny signal to this network, it is best to utilize the cross-bonding system in domestic properties. We can connect to gas meters, gas risers, metal boiler flue, metal outside light, boiler blow-off, or an outside tap. Capacitance methods can also be used here, for example, by wrapping the lead around a plastic light fitting. All of these will usually connect to the LV service in the property and allow a Genny signal to be sent down the LV service and also along the LV main. Multiple connections to multiple properties may be needed to locate the whole LV network. It is essential that the LV network is located using the Genny before any excavation work commences. To locate an LV service, it is preferred to apply the signal to the property. This allows 100% signal on the LV service. This signal is then split as it joins the LV main, usually travelling in both directions along it. With a greater signal on the LV service than the main, the location of the service is easy to establish. When applying a Genny signal to the main LV rather than the house, the greater signal is often on the LV main, making it more difficult to locate the LV service. For multiple LV mains, we now need to refer to our utility plans. This will allow us to see where the best place to apply the Genny signal is. Look out for locations on the plan where you could apply the Genny signal to individual cables, and allow signal cables to be located one at a time in an otherwise congested area. With the LV network now located and marked, we can move on to the location of communications cables. Using the signal clamp to amplify a signal directly onto communications cables is the preferred method. Once connection and clamping methods have been exhausted, the induction method of the Genny should be used. Please note that attempting this induction mode can often lead to mistakes, as the signal usually travels along the better conductor in the footpath, which is usually the power cable rather than the comms cable, whereas with clamp you are more likely to locate the comms. Place the Genny 10 meters away from where you intend to scan with the CAT. It is also important to check for airborne signal from the Genny by pointing the CAT towards the Genny. If the signal increases, it is airborne. If it decreases, the signal you are detecting is coming from an underground utility. Depth estimation on induction mode is far less reliable than connection, and should only be attempted when the Genny is at least 25 meters away. Induction mode can also be used to locate HV cables, these being particularly difficult to locate due to the inability in most cases to apply a connected or clamped signal. With the HV being deeper in a lot of instances than the LV and the two cables running close together, it is common that the induced signal is greater on the LV cable, even when the Genny is above HV. It is good practice to use your utility plans to get an indication of where the HV cable is separated from the LV. For example, a road crossing, and use this position to apply the induced Genny signal. A blind induction sweep should now be performed to check for any other utilities passing through the excavation. With the Genny 10 meters away from the excavation area, it should be placed at 200mm intervals across the area. At each interval, the CAT is used to scan the entire width of the excavation. This should be repeated in at least 2 directions. Now you have a number of utilities marked out. We can now start to null out the utilities we have found and check for anything that might not have been detected using the standard induction technique. This method is easier using 2 people. It can be performed on your own, but it will take a little longer. First of all, locate the utility you want to null out, keep the CAT above the utility, and set sensitivity to maximum. From this position, turn the sensitivity control down 1/4 turn. Instruct the Genny operator to turn the Genny on its side, and sweep it side to side until the signal from the CAT disappears. The utility has now been nulled out, and adjacent utilities can now be detected. With the Genny work complete, you now need to perform a power and radio scan across the excavation to finish off. Before digging starts, the construction team must perform a fresh CAT and Genny survey to verify any prior markups. Hand-dug trail holes must be used to confirm the location of the underground plant. The first choice of excavation is vacuum or air-based techniques. These methods are very effective in avoiding utility damage and also create other efficiencies, as well as reducing the manual handling risks. Excavators should not be used within encroachment lines of buried services, unless a physical barrier and safe system of work has been established to protect the asset. Only toothless buckets should be used when excavating in the vicinity of underground plant. All hand tools must be fully insulated to guard against electrical shock. All-in-one FR and arc flash protective clothing must be worn and must cover arms, legs and torso whilst excavating. These overalls must conform to FR Index 3 and ARC Class 1 and provide a minimum of 8 cal CM2 protection. When excavating, it is important to adhere to the minimum safe excavation distances. Exclusion zones must be adhered to when breaking out the top layer of tarmac and wearing coarse. Once a section of this has been removed, hand digging should start outside the exclusion zones, then moving steadily in, undermining and safely exposing buried assets. The excavation must be retraced a minimum of every 300 mm to ensure you get the most accurate position of any unexposed underground services. When close to utility, an air lance or safety shovels can be used to support the safe exposure of buried assets. During this, the ground conditions should be continually assessed for suitability. If the excavation exposes cables over a distance greater than 1 meter, then support boards will be installed to prevent any bowing damage occurring to them. If your excavation needs to go deeper than 1.2 meters, then a deep excavation and temporary works process is required, along with the permitory and trench support materials. Confined space risks should also be considered. So remember these key messages when following the excavation's safe system of work. During pre-construction and design, our main focus is on implementing steps to eliminate or provide engineering controls to minimize all hazards associated with our work. Ensure that you have a valid permit to break ground, which covers the area you are working in and which is issued by a trained underground service appointed person. Always complete a thorough trace and markup using the data logging CAT and Genny, which is capable of providing depth readings. Remember, the first choice for excavation is vacuum or air-based techniques. Exclusion zones must be adhered to when breaking ground and excavating near services. Always follow safe digging practices and retrace services a minimum of once every 300 mm. When needing to dig close to services, use air lances, safety shovels, and dig carefully to avoid damage. Never assume the line or depth of services.